Okay, an application of stoichiometry is two different things, limiting reactant and percent yield. A limiting reactant, or sometimes called reagent, is the reactant that's entirely consumed when a reaction goes to completion. It limits how much product can be made by one of the reactants. So I have some examples of this. Here I have making sandwiches. Okay, a sandwich is two pieces of bread, one piece of cheese. So if I count up here, I've got 1, 2, 3, 4, 5, 6. So based on this, I could make 3 sandwiches. I'm just going to call it 3 sands. Okay, I have 2 pieces of cheese, so I can only make 2 sandwiches here, right? So which one limits? Which one produces the least amount of product? Well, this one does. Okay, so what I'm left with is 2 sandwiches, which is I'm out of cheese, so cheese was my limiting reactant. And because I only used up 4 pieces of bread, I'm left with 2 pieces of bread. Okay, so this is a non-chemistry example of limiting reactant. All right, now let's look at it from a chemistry point of view. Okay, so here I have hydrogen plus oxygen goes to form water. Okay, and so here's the balanced reaction. I got 2 hydrogens plus oxygen. I don't know why I got a star there. Goes to form 2 waters. Okay, so if I look, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 hydrogens. Okay, based on this chemical reaction, that should produce, it's 2 to 2. Okay, so I've got 2 hydrogens to 2 waters, produces 10 waters. Okay, I'm down there at the very end. I've got also 10 oxygens. All they did was change the colors. So I've got 10 oxygens here. Okay, but based on this one, okay, that basically for every 1 oxygen, I produce 2 waters. And so therefore, this would be produce 10 waters. So which one limits here? The hydrogen limits how much there can be. So my product here, if I count, this is a water, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I had 10 waters. Okay. And green should show up there. Okay. I have how many oxygens left over? 1, 2, 3, 4, 5. I have 5 oxygens left over. So that's how you do limiting reactant. Okay. So now let's do a problem with this. Okay, this is number 94 out of the textbook. Carbon disulfide burns in oxygen. The complete combustion gives the balanced reaction of 1 carbon disulfide plus 3 oxygens goes to produce 1 carbon dioxide and 2 sulfur dioxides. Now in the book, this is they draw out the molecules, but this is the same thing. On the test, I also cannot draw out the molecules, so this is more what it's going to look like. Calculate the grams of sulfur dioxide. Okay, so I didn't leave myself a whole lot of room here, but I want to know how many grams of sulfur dioxide I produce when I have 35 grams of carbon disulfide and 35 grams of oxygen. Okay, and then what reactant remains unconsumed at the end of the reaction. All right. So this, like I said, is applied stoichiometry. So I have to do the same process that I did in the regular stoichiometry, but I got to do it twice. I got to figure out which one of these 2 items here produces the least amount of sulfur dioxide. Okay, so the other things I'm going to need the molar mass of carbon disulfide, and that's 76.16. Again, that's gotten the same way. Okay, 1 times 12.01 is carbon, 2 times 32.07 is sulfur. When I add those up, I get the 0.16. Okay, and then the molar mass of oxygen is 2 times 16, which is 32 grams per mole. Okay, and the molar mass of sulfur dioxide is 32 plus 32.07 plus 32 is 64.07 grams per mole. Okay, so like I said, I have to do the same thing as I did before, which is I start out with the mass. I'm going to start with carbon disulfide because it's the one on the left. It doesn't really matter. So I have 35.0 grams of carbon disulfide. What unit do I have to be in to compare amounts? It either has to be molecules or moles. Okay, molecules, remember, is a much bigger number to work with, so I'm going to go to moles. So how do I go from mass to moles? I divide by the molar mass. So that's going to be 76.16 grams per mole, and I put down what compound I'm working with, and that gives me 0.4596 moles of carbon disulfide. Okay. Now I need to go to moles of sulfur dioxide. So now it's the mole-to-mole conversion. So it's the same 3 steps we did before. The one I want to go to is on top. So I have 2 moles of sulfur dioxide and 2 moles of carbon disulfide. I'm sorry, 1 mole. Oops, hit the wrong button. There we go. Okay, and those are gotten from the coefficient. This is 1, this is 2. So that 2 comes down here. Okay. And that gives me 0.9191 moles of SO2. Now I can go to grams, but I don't want to now because it would be repeating steps. Instead, I'm going to start with the oxygen and figure out how many moles of that's produced. So again, I start with 35.0 grams of O2. Same process. I'm going to divide by the molar mass, which is 32.0 grams of oxygen per mole of oxygen. There's a 2 there. Okay, this gives me 1.0938 moles of O2. Okay, this time my conversion is 2 goes on top and 3 goes on the bottom. So I still have 2 moles of SO2. So it's very important to go to the same product. So at this step, the numerator should be the same for both of them. The denominator may or may not be, but the numerator, the top has to be. Okay, and so that gives me 0.7292 moles of SO2. So just like we did with the bread with the sandwiches, we want to select the one that has the smallest amount, which is this one. Okay. Now, but it wants to know what the grams are of the sulfur dioxide. So the last step is to take the ones the smallest, 0.7292 moles. How do I go from moles to mass? I multiply by the molar mass, which is 64.07 grams per mole. And I get 384, no. Okay, sorry about that. I have to go back to my calculator because that's not what I should have gotten. 0.7292 times 64.07. 46, that's a much better number. I get 46.72 grams of SO2. So that's the answer to the first part, calculate the grams. What reactant remains? Okay, so the one that I didn't circle was this one. This is the one that's in excess or remains. So I come back, and that belongs to the carbon disulfide. So carbon disulfide remains. Okay. Some of the examples in the book want you to calculate the amount. I'm not going to worry about doing that. If you can get this step down, then we will be good. Okay. So that's going to be the end of this video. It's going to be part 1 of part 2.